Howdy guys, we're here to start our gas stoichiometry unit by looking at our notes. Now make sure you get these dates over here that are copied in on the left. Now the first item on the agenda is the ideal gas law. So that is not actually what's going to be on page 2 because we're going to skip around in our notes. So make sure you're paying attention. Look at the ideal gas law, which is going to be on your third page of your notes. So the ideal gas law is this equation right here. And there's really only one equation. It is PV equals NR and T. Now P is pressure, V is volume, and N is the number of moles, R is the ideal gas constant, and T is the temperature in Kelvin, always in Kelvin. We remember this as the Pervner equation. Okay, so here you'll have to use pressure and volume just like you have been using, and temperature like you've been using. Moles is going to come into play because we're going to, but you're just going to use moles like you understand them. Now for R is brand new right here. R is going to be an ideal gas constant. Now what this does is it relates the units, and it's our basic fudge factor that relates all the pressure, volume, number of moles, and temperature units. Now the trick is that R has 4 different values because we have 4 different units of pressure that we can use. So it is absolutely crucial you pick the right value of R. What you're going to look for is what unit of pressure your problem asks you, and that's going to be your value of R. Okay, so let's go ahead and start with an example. Example 17. What is the pressure in millimeters of mercury exerted by 85.5 grams of CO2 at 27 degrees Celsius if the gas is contained in a 15-liter container? A quick thing we can do is start writing down information. Pressure is going to be our unknown. Our volume is going to be 15 liters. Our number of moles is going to be something interesting because we have 85.5 grams of CO2. So what I'm going to have to do is I'm going to have to take 85.5 grams of CO2 and I'm going to have to convert this to moles. Okay? So grams of CO2 to moles. And the molar mass of CO2 is 44 grams per 1 mole. When I do that calculation, I end up with 1.94 moles of CO2. Now, the value of R I'm going to have to use is going to be picked based off of my pressure. So notice that here my pressure was, it's asking me in millimeters of mercury. So my value of R I'm going to have to use is going to be this one. I'm going to use millimeters of mercury. So that's going to be 62.4. And the units are liters dot millimeters of mercury divided by moles dot Kelvin. Now those units are just there to basically cancel out all the rest of the units except for your other one, except for the one you want. And then my temperature is going to be 27 degrees Celsius. Okay, and I'll have to add 273 to change it to Kelvin. So that's going to end up being 300 Kelvin. Okay, so I'll go ahead and write over this. I'll delete this in a second. But what you're going to have to do is just substitute all those in to your equation. PV equals nRT. So my pressure is my X times 15 equals my number of moles, which is 1.94, times my value of R, which is 62.4, times my temperature, which is 300. And then I'm going to have to isolate X by dividing both sides by 15. Okay, once that's done, those cancel out, and my value of X is now going to give me 2,421 millimeters of mercury, but I need to approximate that to the correct number of sig figs. And since I have 2 sig figs here, I want to approximate to 2 sig figs in my answer. So that's going to be 2,400, 2,400 millimeters of mercury. And that's my answer for that example. So you may ask yourself, wow, that's a lot of work. If you are able to glean this information without writing down, if you're able to take this stuff right here and able to just pull it off of the problem without writing it down, you're welcome to do that. What I must see on your work is I must see this part right here. All right, I must see this. Okay? So I moved everything around so it's easier to see, but that's the work you need to show for example 17. Example number 18, it asks for the mass of 120 liters of SO2 at a temperature of 40 degrees Celsius and a pressure of 185 atmosphere. So easy thing to do is to go ahead and change your temperature to Kelvin. So 40 plus 273 is going to be 313 Kelvin. Now, again, I'm going to use my Pernod equation, my PV equals nRT. Now it is asking for the mass right here. So since I've got asking for the mass, that's actually grams, but grams is nowhere in the ideal gas law. What is in the ideal gas law is moles. So I'm going to have to find moles and be able to find my grams. So those two are related, and that will show up on your test. So my pressure is going to be 1.85 atmospheres, and my volume was 120 liters. Now my number of moles is what I'm looking for. I'm looking for my number of moles. Now the ideal gas constant is going to be R. Now I have to choose the right R value. What I'm going to look at is I'm going to look at my pressure, which is atmospheres. So I'm going to go up here to my ideal gas constant, find atmospheres right here. Okay, and that's the one I'm going to use. So it's going to be 0.0821, 0.0821. Okay, and then my temperature is going to be 313 Kelvin. So now I need to isolate my unknown, which is N. So I need to divide both sides by 0.0821 times 313, 0.0821 times 313, and then they will cancel out, and my number of moles is going to be 8.639. Now that is too many sig figs, but I'm not done yet. So that is 8.639. I added a few extra sig figs because I want to, you'll see why in a minute. So this is the number of moles of SO2. Now it asked me for the mass, so I need to go ahead and convert moles of SO2 into grams of SO2. Now the molar mass of SO2 is going to be 64 grams per mole. So that means that now that I have 8.639 times 64 is going to be 552.898, something like that. Which now means I need to round to my significant figures. So I'm going to do it 2 sig figs. So it's 550 grams of SO2. Okay, so lickety split, that's done.